Okay, let's say right now we got ourselves into these matrices. It's now on the previous slides I've shown you how. I can also rewrite it into something like this. The A disappear, but right now I have the A inverse on the right side. Okay, instead of this one A. How do we get that? Okay, let's look at the proof. I start myself with ax equals to b, and I want to make this a disappear, so I multiply with the inverse. Remember, for matrices, if I multiply for the left hand side, for this one, this one need also to appear on the left hand side, right? And then a times this one, I know I can get identity, and the identity disappears for me to get myself to x. So that's how just now what I mentioned to you, that from here we're going to get ourselves into down here. Okay, so let's continue. Okay, so for you to use that method, you need to find firstly the A inverse. But for this question, the A inverse is not supplied, so you need to find it sometimes in the exams you need. And you mentioned here you want to use by adjoint method. Well, technically you have learned adjoint method on the lessons before this, so I'll be quick. And once we find the inverse, we can use it to solve this one here. Notice that this one, this particular matrices is the linear of the part A. So I can use it somewhere. I can say that this is A. I can say that this is A, x equals to B. Alright, but before that, we need to find, as I mentioned just now, A inverse first by using adjoint. I'm not going to bore you so much with it because you have learned the adjoint on the previous slides. Firstly, you need to find the minor, the determinant, and then you need to find the cofactor, and then you find the adjoint, and then you multiply with the 1 over determinant, then only you got yourself the inverse matrices. So this is the inverse of the A inverse. Alright, so let's continue. So just now I've mentioned there's our A x equals to B. Our linear equation I will change into the matrices form, and this is I can declare as A x equals to B. Remember, I can change it into x equals to A inverse B. With A inverse, what we have find by the adjoint just now. Ooh, pretty. And yeah, that's what I said. We got it. Okay, so in exams, that's what we want to write it down. Okay, this is what we want to write in exams. Minus the face. Okay, and then once you got that, you can multiply the x and b A inverse, sorry, the A inverse, I can multiply with B. This is what I get behind. Just use your calculator to calculate it, and you can solve it. You got yourself that. So once you got that, so now you're able to solve x1, x2, and x3. So what you want to achieve is from the linear equation, you find the inverse, and that's how you solve it. Okay, let's have a look at another example. Let's say you got yourself this time A inverse, and you given this type of matrices. Alright, have a look first. These linear equations here. Can you find any similarities with the, let's say with the A? I'll give you some hint. You can see that it's a multiplier. It's a multiplier of A. What do I mean by that? Hey, if you look here, this is 9, this is 3, this is 6, this is 3, 1, 2. Basically, it's a multiply. But I can say it's a times 3 multiply. So I can write down our equation here. First, I change it to the matrices form. And I can write down this one as that again, and I can declare this as 3a. If you are able to see it straight away, you can skip the steps to these steps. I will personally do it this way. Okay, and then as I mentioned to you just now, about the ax equals to b, we can get ourselves into this one. And of course, you can see the 3, simply divide it to that side, and you got yourself into 1 over 3. Okay, and then from here we got ourselves the value of A inverse. We got the B is this one here. The A inverse is given in the question just now, so just substitute the inside, and this one here you can solve it by using your calculator. Multiply the 1, 3 as well, and we got that. And once we reach there, we declare that x1, x2, and x3. Okay? Thank you for watching. Please comment, share, like, and subscribe.